Okay, this is the first part of the review for our unit on centripetal force, torque, and universal gravity. The first questions that we are going to go over on page 1, they have to do with centripetal force. Now, just like last time, I'm not going to go over questions that you're supposed to find from your notes. And those would be the top questions from number 1 down to number 4. These are all from your notes. You need to look them up and fill them in for full credit. Now 5, 6, and 7 are our rule of ones questions. So I'm going to slide this up to put those more in center view. I've also written down right here all of the equations that you will be given on the test. So remember, when we do the rule of ones, we have to think about what the question is asking. We're asked for centripetal force. We're really dealing with this equation down here. Okay, so for your rule of ones, always going to be using the big combined equation. I'm going to rewrite it under number 5 to do one practice for you. Now remember, with the rule of ones, that what we are doing is substituting what they give us in the problem into the question and leaving everything else as simply a value of 1. So in this question, they tell us that the velocity doubles. So mass will stay a 1, velocity doubled, but remember it's v squared, so I have to write my little squared superscript, and the radius is going to stay the same. Now some of you that said you've been having trouble having your rule of 1 problems, think of it as if you're just doing another math problem, but this time you don't need a calculator because all the numbers are really small. So our top is 1 times 2 squared, so we get 4. Our bottom number is just 1, so what happens to the force? It gets multiplied by 4. I'm not going to work number 6 and 7 for you because you should be able by now to work rule of ones questions. I will, however, go ahead and fill in those answers so that if you pause, you will be able to do the same. There is number 6 with all of the necessary work. Pause again to work number 7. And there is number 7 worked for you. Okay, I will now push the paper up and take a look at problem number 8. Now remember that the first thing that I like to do going through one of these tests or reviews is to identify all the numbers given to me as I read the question. So we're asked for centripetal force experienced by a 2,100 kilogram car traveling 25 meters per second through a curve with a radius of 63 meters. Now, this is all very, very simple if you remember what equations to use and what the variable units are. So if I read through my problem, I can first identify that 2,100 kilograms is a unit for mass. Next number they give me is 25 meters per second. That unit is for velocity, and 63 meters. That's a measurement for distance, but if I remember my equation, I don't have distance. What I do have is radius, which is a distance. The question has asked to find the centripetal force. If I look at my equations, remember I need to find the equation that has everything except one variable. So if I looked at my list, I don't have acceleration, I don't have centripetal force, I can't use these equations. I need to use this one. It has everything that I've listed, has what I'm looking for and what I'm given. So this is the equation that I'm going to use. I've rewritten the equation on my paper so that I'm ready to substitute. I first substitute my mass. This is very easy if I've written all of my units out on the left-hand side of my paper. My mass is 2,100 kilograms. So I've simply substituted the mass given into the equation. Same thing for velocity. They gave me a velocity of 25 meters per second. Remember, I'm only squaring the 25. You only square the velocity. All of this will be over the radius. They gave me a radius of 63 meters. Okay, next I take my calculator and I'm going to plug in those numbers. 2,100 times, I need to use my parentheses here, 25 squared, just 625. So I multiply those together and I get 1312 500. Remember, this is all over 63. So I divide and I get an answer of 20833. I'm just going to go ahead and round that down. That's a pretty big number already. You could say 0.3, 0.33. Those would all be fine as well. And the last thing I'm missing is my unit. I know what unit to use by going back and seeing what variable I was asked for. I was asked for force, and force is always measured in newtons. Okay, so that's one centripetal force problem down. On number 9, we're asked for centripetal acceleration this time, so we're going to be using a different equation. So I'm looking for AC. They give me kilograms. Remember that kilograms is a unit for mass. I have 1.3 meters per second. That number is representing velocity. They also give me 22 meters. Again, that's my distance, which represents my radius. They ask me a second question here. They ask me for centripetal force. So there's two things to be doing. First, I need to find acceleration, and I also need to find centripetal force. I can use this same equation and go ahead and use m, v, and r. That will give me the answer. But since I'm also asked for centripetal acceleration, instead this time I'm going to use these equations. First, I find centripetal acceleration, and then I can plug it in right here. Again, if you like this formula, you can work it this way, and then the second formula you work is this one. It will get you the same answers. Okay, so my first one, to find just centripetal acceleration, I'm going to do v squared over r. My velocity was 1.3. That has to be squared, and then divided by a radius of 22. Really simple here. 1.3 squared divided by 22. And I get an answer of 0.077 is how I'm going to round that. Okay, now that's my centripetal acceleration. The next thing that I want to do is find centripetal force. My secondary equation for that was mass times centripetal acceleration. Okay, so I'm going to take my number that I just got here, plug it in for centripetal acceleration. I want to take my mass from over here, 82 kilograms, and plug it in right there. So I have 82 times 0.077. Now, if I were to leave this in my calculator, I could do that and just multiply by the 82. I'm going to get an answer of 6.3. Remember, it's a force. Newtons are my unit. Oh, I'm just realizing I forgot my unit here. But I remember that I wrote down what I was solving for. It was acceleration. That's meters per second squared. There's my first answer. There's my second answer. I want to show you a couple things. Let's pretend that I had cleared that long number out of my calculator and just had 0.077. And I multiplied that by 82. I still get an answer relatively close, 6.314. Don't worry, the bigger your numbers, the bigger you're going to vary from what I might have, but that's okay because you're doing the same thing, you're in the right range. Okay, next centripetal force question. Again, if we get to a question that you know you can work on your own, pause it and then restart to check your answer and make sure you did the right steps. So in my next problem, I have a much smaller item. I have a mass of 0.035 kilograms, and I have a string that is 0.82 meters. This stopper on the string is swung in a circle with a velocity of 3 meters per second. The question is, find the centripetal force. Because they don't ask me about acceleration, they only ask centripetal force, I'm going to use the combined or long form equation and simply plug in. This is an easy one like the first one. I put my mass in, 0.035. I use my velocity, which is 3. Remember that you only square the 3. I saw many people mess that up on their quiz and on their practice problems. I'm going to divide all of that by my radius, which is 0.82. So when I do my calculator, I'm going to move it over so you guys can see my work. I'm going to do 0.035 times 3 squared. I know that that's 9. I'm just going to punch that into my calculator. So I end up with 0.315 over 0.82. Divide that out, and I get an answer of 0.38. Again, not a complete answer till I have units. I was looking for a force, so my unit is newtons.